Hi, Logan. So I am here ready to help you out with some more problems that you're struggling with. So I'll share my screen and we'll get started. This first one says a herd of dinosaurs made paintings in the sand with their claws. Each baby dinosaur made 15 paintings and each adult dinosaur made 7 paintings. The entire herd made 208 paintings in total, and there were 3 times as many baby dinosaurs as adult dinosaurs. So what we're going to have is we're going to create 2 equations again, okay? So equation number 1 is going to focus on the number of paintings, okay? And so this is what I do every time. I just come up with a plan, all right? I just slow down and I go, okay, look, I have to have 2 equations here to actually solve this. And then number 2 is going to be the number of dinosaurs, okay? And so that's how I plan these for each one of these. So I'm going to have 2 different equations, and that's how I figure it out. Okay, the entire herd made 208 paintings, and there were 3 times as many baby dinosaurs as adult dinosaurs. So let's just go ahead and we'll call, let's label B is the baby dinosaurs and A is the adult dinosaurs, okay? And I don't know how many there were, but there were 3 times as many baby dinosaurs as adult dinosaurs. So I know that the number of baby dinosaurs was going to be equal to 3 times, right, the number of adult dinosaurs, or just B is equal to 3A. And that gets us our first equation, okay? Now our second equation is going to talk about how many paintings they made, and we don't know how many there are, but we know that each baby made 15 paintings and each adult made 7, and they made a total of 208. So I know that for every baby there were 15 paintings. So I know that 15 times B, right, 15 paintings for every baby, plus 7A, so there were each adult made 7 pictures, and the total number of pictures was 208. And then I have my 2 equations now, and I'm just going to erase this one just so it just kind of gets out of our way. But here's our 2 equations. And again, there's always 3 different ways that you can solve a system of equations. One, you could graph them, so you could actually graph both of these, and you graph them, and you've got this line that comes in this direction, this line comes here, and where they meet, that's going to be your solution. That's one way, but these actually look pretty hard to graph. The next way you could do it is through elimination. That's where you figure out how you can eliminate the A or the B in order to do that. In order to do that, you have to have your AX plus BY. You have to have it in standard form, right, is equal to C. And this one is, right, but this one isn't. So you could do that, or you could do it by substitution. And with substitution, you just use, hey, if one of the equations already tells you what its value is, then you could substitute it in the other equation. And I know what B is. I know that B is 3A. So I'm going to go ahead and I'm going to substitute that up here. And that's how I'm going to actually solve this, okay? So I'm going to do 15 times 3A plus 7A is equal to 208. And then I just do this math, right? So I get 5 times 3 is 15, carry the 1. 1 times 3 is 3, plus 1 is 4. So I get 45A plus 7A equals 208. And then I'll just add these 2 together. So that's going to give me 7 plus 5 is 12, and then 4 plus 1 is 5. So I get 52A is equal to 208. And then I'm going to divide both sides by 52. And of course, if you just do a series of numbers here, you get 52, and then you get 104, and then you get 156, and you get 208. And so you see that 208 divided by 52 is 1, 2, 3, 4. So we know that there are 4 adults, okay? So it wants to know how many adults, and now we know there were 4 adult dinosaurs. And to find out how many babies, we'll just substitute here. 3 times 4 is 12, so we know there were 12 babies. So again, it's just that idea of understanding. I always start here because this makes creating these equations really easy. And so what I do is I always think about, well, what kind of equations can I write? And I'm going to need a system of equations to solve this, okay? The next one says, hey, Toby skated from his house to the beach at a constant speed of 8 kilometers per hour. and then he skated from the beach to the park. So what I do is like, I want to draw a picture, okay? So here's his house, right? So here's Toby's house, and it says he skated from his house to the beach. And let's just go ahead and we'll just say, okay, you know, here's the beach with the rolling waves, right? So here's the beach. And we know that he did that at a constant speed of 8 kilometers per hour. So, and then he skated from the beach to the park. And then, you know, we could just draw a swing set or something right here, right? And so here's our little swing set. And so here's the park. And we go, okay, so here's the park. And so here's the beach, here's the park, and here's his house, okay? And that just kind of helps me understand what's happening here. And we know that he went from here to here, and he did it 8 kilometers per hour. And here he went from the beach to the park at 7 kilometers per hour. And then it says the total distance that he skated was 20 kilometers. And so I don't know if you recognize this, but I'm pretty sure we did this exact same problem before. And so this is still really, I think you're really struggling with this idea. So I would say whenever you can, draw a picture in math, because it makes what's happening a little bit more, it makes it a tiny bit more sense. So, and it took him twice as long to get to the park. So we know that to get from here to here took twice as long as it did for him to get from here to here, okay? So let's just go ahead and say that. So to go to the beach, well, let's just say to go to the park, it took him twice as long to get to the park as it took him to get to the beach. So we know that however long it took him to get to the beach, it took him 2 times that to get to that park. Or just 2b, right? So we're looking for our first equation is going to be p equals 2b. So we're going to look for that. Well, we can eliminate this one because it has b equals 2p, and we can eliminate this one. And it leaves these two, right? Because they're both p equals 2b. And now we have to figure out, well, we know he did a total of 20 kilometers. And we don't know how far it was to the beach, but we do know that he traveled at 8 kilometers per hour to get to the beach. Plus, we know he traveled 7 kilometers to get to the park and per hour. And we know that when we get it all finished, we're going to equal 20. And there's our second equation. So now we're just looking for this one. And we see it's not this one, it's this one. So again, this was one I thought we had done together. I'm not sure. It just seemed really, really familiar to me. So again, whenever you're solving these, you're always looking for a system of equations, and then you just figure out what information you have here to help you out. And then number 3. So number 3, it's different, you know, it's a different math here. They're wanting us to match the correlation coefficients with the scatter plots. And so let's just take a look at these, okay, and see if we can figure out what they are, okay? So what we're seeing is R is the slope, okay? So one of the things you want to make sure you understand is R is equal to the slope. And so hopefully we can figure these out. And so what you want to do is you just want to create a line of best fit. The line of best fit has the digits as close to the line as possible, right? So the line of best fit right here, I need to do a slanted line. The line of best fit here would probably be somewhere right around here, right? And this one, the line of best fit would probably be like this. This one, the line of best fit would probably be like this. And this one, it would probably be like that. Does that make sense? So again, it's just kind of looking at the line of best fit and then just notice those slopes. So what I notice is this is a negative slope. And so I'm just going to go ahead and I'm going to write down everything I know, right? So this is a negative slope, and this is a negative slope. And this is a positive slope. And this is a positive slope. And then I just want to take a look, and I see that I have 2 negative slopes and I have 2 positive slopes. So it makes sense, right? As I start to move these things around. And then I just go, okay, look, well, scatter plot A and B, if you take a look at these, which one seems to have a steeper slope? And so when we take a look at this one is steeper, right? So I should see that this number its absolute value should be larger than this one, which tells me then that scatter plot B is going to be, look at the absolute value, 0.75 is larger than 0.41. So this is the steepest slope. So this is scatter plot B, right? So we're going to move, this one is B. So we'll just put a B there. And this one's going to be A, okay? So, and I know with these, I think you just pick them up with your mouse and move them into the different boxes. So the scatter plot A is going to be 0.41, okay? And scatter plot B is the negative 0.75. And then we'll look at the two positives. And again, this one is steeper than this one. So again, this one should have a larger absolute value than this one. And when I see that, then I see that this has a larger absolute value. So this is going to be D, and this is going to be C, okay? And so that's how you do them. Again, I always just look at the pictures. I go ahead and I draw a line of best fit. I determine which one's positive and negative. And then for these, I don't actually have to find the slope, although you can. I mean, if you want, you can find the slopes. And you could also see, if I took these two numbers right here, this is 6 minus 3, so it's going to be 3 over, and then this is 2 minus 5, which is negative 3. So for this one here, it would be negative 1, and the one closest to negative 1 is negative 0.75. So you could actually do that, and then you could do the same thing here. You could take this point here and this one here, and this would be 6 minus 3 again, so you'd have 3. And then you'd have 3 minus 8, which is 5. So you're going to have a negative 3/5, and a negative 3/5 is right about 0.6, right? So you'd have negative 0.6, and so you'd go, okay, this one was negative 1, and this was negative 0.6, and then you go, okay, well, I don't have those, but I do have these other numbers that show me that same information, and so I know these are the ones. So evidently their line of best fit was different than mine, but at least I could still see this one is still steeper, and it's going to be this one, and this one is not as steep, so it'll be that one. So that should get you going on those. And then again, if you need more help, just email me again. All right, I'll see you later.